So, one of the things about ecosystems, even though we just basically said that ecosystems are defined by a primary species, is that unlike the atmosphere, maybe unlike geology, as we're going to discuss here in a little bit, and certainly unlike hydrology, is ecosystems don't have a single energy source that we can really clearly trace. It doesn't have an open system coming in one conduit and then exiting another clear conduit. There's multiple different ways that energy can enter into an ecosystem and leave an ecosystem. And certainly solar energy is one of the primary ways we can measure how much solar energy a plot of land gets and estimate how much energy all the vegetation is absorbing from that solar energy and then delivering it into its cellular structure. We can measure how much moisture falls and do the same thing in terms of measuring. And then we can look at how much water flows through an area, as we're seeing right here with this particular river, which happens to be the Yellowstone River. And this is Walter the Moose. I'll tell you about Walter here real quick in a minute. Those things can be measured. What becomes really difficult to measure then is the pathways in which matter and energy move through these systems by Walter, by coyotes, by birds, all of these different organisms that have their own rhythms and movement patterns. And oftentimes those movement patterns are not typical. So there's many ways that energy is going to find its way through a plot of land. And those will differ from year to year. A year of drought is not going to have the same movement patterns and energy patterns in a location that a traditional typical year is going to have. Or a year where you're hydrologically rich, where there's so much water that it's a 1 in a 500-year flood event. Very different. So things change over time, things change over space. It makes it really difficult to map out all of these different conditions that food webs are going to then produce. What we can say, though, is that ecosystems are self-regulating and self-sustaining. And that seems like a little bit of a conundrum, because we can say, oh, we're in a drought condition, like the ecosystem is suffering. I can see the trees dying. But it's that drawback of energy where plants are in a system of not taking up energy that basically results in a new system emerging, or the system retracting, so it's not overextending the energy that's available to it. It's not like a bank account where you can go in and ask the bank for a loan and sort of run on a credit. Ecosystems don't work that way, and so because they don't, they have to regulate themselves by trimming back, by individuals within that system dying back, so they can be sustaining. And then you get to a critical point where there, like any system is, like your bank accounts, your home line of credits, where there's just not enough energy coming into a system, or the right type of energy, where the system fails, but it's replaced by another system. And the intent is that the systems are always stable. So this is important. It's also important to note with things like conservation that we can't look to keep something going in perpetuity, because this is what we think is the way nature should look like. So you can't walk into the Cuyahoga Forest and say, this is the way the forest should look. These are the number of oak trees. This is where the pine trees should be. This is how many squirrel we should have. Those things change over time, because the energy in the matter that flows through the system is going to change over time. And by trying to impose a human condition of this is what's appropriate here, it usually results in failure of the system and an expenditure of human resources beyond the capability of what most taxpayers are going to think is okay. So the big thing is to let the ecosystems mostly manage themselves and keep our hands off of that. Um, some of the big failings that we have seen is things like no burn policies across North America. Um, that definitely changed the nature of energy through the system, and we just loaded up energy, and now we're dealing with all these mega fires that were going to occur because we loaded up energy. But also we've got hotter, drier temperatures, which is an energy structure that's making things even worse. So lots of interacting components within an ecosystem. And I've mostly talked about the living components being regulatory, but the non-living components are critical to ecosystems. That's the nutrients, that's the sunlight, and it's the transfer of those with the interaction of the biota that together make a system run.